Okay.
Good morning and a very warm welcome to respected Dr. Paresh Patel sir, Dr. Khushbu B. Desai, head of the department, beloved lecturers, and dear students. I, Mr. Abhishek N. Patel, once again welcomes you all for our next exciting session on the topic of symmetry and group theory in chemistry and its application. It's our privilege that Dr. Paresh Patel sir is again joining us for today's webinar. In the last lecture, he has given excellent subjective knowledge on the topic. Sir, everyone learned a lot and benefited very much from your lecture. Thank you so much, sir. Now, I would like to request Dr. Paresh Patel, sir, to continue with the session. Over to you, sir.
Thank you, Abhishek sir and Khushbu madam. So, dear students, good morning, all of you. So, yesterday we discussed about the general introduction about the molecular symmetry and point groups. Today we are going for the actual our syllabus of the MSc semester one, that is matrix, types of matrices, inversion of matrix, determinant of the matrix, then matrix representation of our different symmetry operations, then reducible, irreducible representations, great orthogonal theorem, then construct a character table for C2V point group, C3V point group, and applications of group theory in the sigma bonding. So let us start first with the matrix. Okay, generally, matrix can be represented as combination of the numbers arranged in a rectangle array and combined with the another matrix in a following definite way. So matrix can be represented as numbers of the rows and numbers of the columns. So as for example, matrix A can be represented as A11, A12, A13, and so on, AM, A1N. Similarly, A1, A21, A22, A23, and so on, A to N. Similarly, we can represent it as A31, A31, A32, A33, and so on, A3N. And finally, this can be represented as AM1, AM2, AM3, and so on, AMN. So matrix can be represented as the numbers of the rows and numbers of the column. This is known as first row. This is known as first column, second column, third column, and fourth column. So anyhow, matrix can be represented as a rectangle array as the numbers of the rows and numbers of the column. So matrix can be represented as M by N. M is equal to numbers of row and can be represented as numbers of the column. So dimension of the matrix. Dimension of the matrix can be represented as numbers of the rows and numbers of the columns. A is equal to 1, 2, 3, 4. This is known as 2 by 2 matrix. Why 2 by 2 matrix? Here, number of the rows is equal to 2, numbers of the column is equal to 2. So this can be represented as 2 by 2 matrix. B is equal to 1, 2, 3, 4, 5, 6. This can be represented as 3 by 2 matrix. The dimension of this matrix is 3 by 2. Why? Here, numbers of the rows is equal to 3 and numbers of the columns is equal to 3. Sorry, 2. So this can be represented as a 3 by 2 matrix. Now summation and subtraction. And subtraction. Summation and subtraction of any two matrices is possible. Summation and subtraction of any two matrices are possible if the numbers of the rows and numbers of the column of the both these matrices are the same. Suppose A matrix A is equal to 5, 6, 7. 8, 9, and 10. Matrix B is equal to 3, 4, 5, 5, 6, 7. So here, in case of the matrix A, 2 rows and 3 columns. It means the dimension of this matrix is 2 by 3. And matrix B is also 2 by 3. So here summation and subtraction can be possible. So if you go for the A plus B is equal to first element of the first row and first column. So 5 plus 3. This is the first row, first row. Now, similarly, second, first row, element of the first row, second column of the both these matrices, 7 plus 5, 8 plus 5, 9 plus 6, 10 plus 7. So is equal to 8, 10, 12, 13, 15, 17. Okay, so this is the summation of any two matrices. The summation of any two matrices is possible if the numbers of the rows and numbers of the column of the both these matrices are the same, or we can say dimension of both these matrices are the same. Then and then the addition or summation can be possible. Similarly, subtraction. In case of the subtraction A minus B, if you go for the A minus B, then subtraction from A, the resultant matrix can be represented as 2, 2, 2, 3, 3, and 3. So anyhow, subtraction and subtraction can be possible if the both the dimension of both these matrices or numbers of the rows and numbers of the columns are the same. Multiplication. Next one is the multiplication or combination. Multiplication or combination of any two matrices are possible. Multiplication or combination of any two matrices is possible if the numbers of the rows of the first matrix is equal to numbers of the column of the second matrix. Okay, matrix A is equal to, suppose combinations or multiplication 1, 2, 3, and 4. This is two-dimensional matrix. Okay, if we take three-dimensional matrix 1, 2, 3, 3, 4, 5. B is equal to 1, 2, 3, 4, 5, 6. Okay. Now, combination or multiplication of any two matrices is possible if the numbers of the rows is equal to number of the column of the second matrix. Or we can say number of the column of the first matrix is equal to numbers of the rows of the second matrix. Then and then combination or multiplication is possible. Now here, matrix A consists 2 rows and 3 columns. Matrix B consists 2 columns and 3 rows. So here combination or multiplication can be possible. A cross B is equal to, we have to go for the first row, first column. So first element of the first matrix and first element of the second matrix. 1 1 plus second row, second column, second element of the first row and second column of the second matrix. So 2 by 3 plus 3 by 5. Similarly, we have to go for the second row and first column. So this is the first row, first column, second row, first column. So 3 by 1 plus 4 by 3 plus 5 by 5. Similarly, first row, second column, second row, second column. One by 2 plus 2 by 4 plus 3 by 6. Second row, second column, 3 by 2 plus 4 by 4 plus 5 by 6. So resultant matrix 1, 6 and 15 is equal to 22. 1 plus 6 plus 15, 22. 3 plus 12 plus 25 is equal to 40. 2 plus 8, 18 is equal to 28. 6, 16, 30. It means 42. Sorry, 52. 46, 52. So this is the combination or multiplication of any two matrices. Now, character of any matrix or trace of matrix. Character or trace of matrix can be represented by chart. And character of any matrix is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, character or trace of this matrix is equal to summation of diagonal elements. So, character of this matrix is equal to 1 plus 5 plus 9. So, character of this matrix is equal to 50. So, dear students, how to find out the character or trace of any matrix is nothing but the summation of diagonal elements. This can be recognized as a diagonal position of this matrix. Okay, so what is character or trace of matrix is equal to character or trace is equal to summation of diagonal elements. This position can be represented as diagonal position of the matrix. Next one is determinant. Just for example, A is equal to 1, 2, 3, 4. The dimension of this matrix is equal to 2. Why 2? This is 2 by 2 matrix. This is 2 by 2 matrix. So in this case, determinant of A is equal to combination of diagonal elements minus combination of other than diagonal elements to give the determinant of this matrix. So remember, dear students, in case of the two-dimensional matrix, combination of diagonal elements minus combination of other than diagonal elements. So 1 fourths are minus 3 twos are is equal to 4 minus 6 is equal to minus 2. So determinant of the two-dimensional matrix can be represented as combination of diagonal elements minus combination of other than diagonal elements. In case of the determinant for the three-dimensional matrix, A is equal to, suppose 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, determinant of this matrix can be represented as, this is the first element of the first row and first column, and then remainings are 5, 6, 8, 9, just like this one. Okay, minus 2. This is the second element of the first row, and then remainings are 4, 6, 7, 9, plus 3. This is the third element of the first row. Remainings are 4, 5, 7, 8. Okay, so again, these are the two-dimensional matrix. So we can conclude that the combination of diagonal elements 5 nines are minus 8 6 minus 2. Combination of diagonal elements 4 nines are minus 7 6 plus 3. 4 8s are minus 7 5s are is equal to 145 minus 48 minus 2 36 minus 42 plus 3 32 minus 35 is equal to minus 1 minus 6 plus 3 minus 3 is equal to minus 1 minus minus plus 12 minus 9. So answer is equal to 2. So in case of three-dimensional matrix, first of all, we have to go for the first and remainings are 5, 6, 8, 9. Similarly, we have to go for the minus 2. In case of the second, we have to go for the minus and 2. And the remainings are 4, 6, 7, 9. And plus 3. Remainings are 4, 5, 7, 8. So in this way, we have to find out the determinant for the three-dimensional matrix. Okay. Now next title is the types of matrix. Types of matrices. Now, exam point of view, dear students, exam point of view, this is most important title and this is very easy title. So, matrices can be classified into first one is square matrix. What is square matrix? If the numbers of the rows and numbers of the columns are the same. If the numbers of the rows and numbers of the columns are the same, that can be represented as a square matrix. As for example, matrix A, the numbers of the rows is equal to 3, numbers of the columns is also 3. It means this can be represented as a square matrix. Second one is diagonal matrix. Now, what is diagonal matrix? In case of the diagonal matrix, B is equal to 2 0 0 0 4 0 0 0 6 or anyhow. Okay, this can be represented as a diagonal position of this matrix. And in case of the diagonal matrix, the value for the diagonal position of these elements have some definite values and remainings are the 0 can be recognized as a diagonal matrix. Third one is unit matrix. In unit matrix, the value of diagonal position of these elements are 1 and remainings are 0. So this type of the matrix can be represented as a unit matrix. Fourth one is row matrix. This type of the matrix consists only one row. Next one is column matrix. So this type of the matrix consists only one column. Next one is null matrix or zero matrix. A is equal to 0, 0, 0, 0. If the value of all the elements are 0, so that type of the matrix can be represented as a null matrix. Then last one is singular matrix. If the determinant of this matrix is equal to 0, so that matrix can be represented as a singular matrix. Now, the determinant of this matrix can be represented by combination of diagonal elements minus combination of other than diagonal elements is equal to 0. So this type of the matrix can be represented as a singular matrix. Next title of this matrix inverse of matrix. Now, to find out the inverse for the two-dimensional matrix and three-dimensional matrix, both are the different. So first of all, how to find out the determinant for the two-dimensional matrix, that is also important. As for example, one example which is related to how to find out the inverse for the one-dimensional matrix. A is equal to 8, 3, 5, 2. Okay, the dimension of this matrix is equal to 2. Here, number of the rows is equal to 2, numbers of the column is equal to 2. Now, to find out the inverse for the two-dimensional matrix and three-dimensional matrix, both are the different. So this can be represented as a A inverse. Now, in case of two-dimensional matrix, first step to find out the determinant of this matrix, change the position of the diagonal elements. And we know that these are the diagonal position of these elements. So change the position of the diagonal elements. Clear? Second one, change the sign of other than diagonal elements. So we have to change the position, change the sign of the other than diagonal elements. And third one, to find out the determinant of this matrix. The determinant of this matrix, 8 to the 16 minus 5 3 is 15 is equal to 16 minus 15 is equal to 1. And last one, divide each element of this matrix by the determinant of this matrix is equal to 2 minus 3 minus 5, 8. Okay, so this is the procedure to find out the inverse for the two-dimensional matrix. So dear students, how to find out the inverse of this matrix? First of all, we have to find out the determinant of this matrix. Second step, change the position of the diagonal elements. Third step, change the sign of the other than diagonal elements. And finally, divide each element of the matrix by determinant of this matrix. Okay, so this is the how to find out the inverse for the two-dimensional matrix. Now, how to find out the inverse for the three-dimensional matrix? So exam point of view, to find out the inverse for the two-dimensional matrix as well as three-dimensional matrix. These are the most important. A is equal to, suppose one three-dimensional matrix is 1, 4, 3, 2, 1, 0, and 1, 3, 2. Now find out the inverse for this three-dimensional matrix. So first of all, we have to find out the determinant of this matrix. Okay, in case of three-dimensional matrix, A inverse is equal to adjacent A divided by determinant of this matrix. So first of all, determinant of this matrix 1, 1, and remaining are 1 to the minus 0, minus 4, second element, remainings are just a minute. 1, remainings are 1, 0, 3, 2, minus 4, second element of the first row, remainings are 2, 0, 1, 2, plus 3, remainings are 2, 1, 1, 3, is equal to 1, 2 minus 0, minus 4, 4 minus 0, plus 3, 6 minus 1, is equal to 2 minus 16 plus 15, is equal to 1. So the determinant of this matrix is equal to 1. So determinant of this matrix is equal to 1. Now, how to find out the adjacent A? To find out the adjacent A, we have to find out the value for C11, C12, C13, C21, C22, C23, C31, C32, and C33. And then arrange the numbers of the rows and column. That is known as the adjacent A. So how to find out the value for C11 is equal to minus 1 and m plus n and remaining values. So in case of C11 is equal to minus 1, this is known as C1, the first element of the first row and first column. It means first row and first column. M is equal to numbers of the rows and n can be represented as the numbers of the column. So remainings are 1, 0, 3, 2 is equal to minus 1 raised to 2. And the value of the determinant of this matrix 2 minus 0 is equal to 2. Minus 1 raised to square, minus 1 square is equal to plus 1. So the value is equal to 2. Similarly, C12 minus 1, first row, second column. First row, second column means numbers of the row first, numbers of the column second. Now remainings are 2, 0, 1, 2 is equal to minus 1 raised to 3 is equal to minus 1. 4 minus 0. So the value minus 1 raised to 3 is equal to minus 1 and plus 4. So the value is equal to minus 4. Similarly, C13 is equal to minus 1, 1 plus 3. First row, third element. So remainings are first row, third column. It means remainings are 2, 1, 1, 3 is equal to minus 1 raised to 4. So 6 minus 1 is equal to minus 1 raised to 4 is equal to plus 1. And 6 minus 1, so the value is equal to 1. So the values of C11 is equal to 2, C12 is equal to minus 4, C13 is equal to 5. Clear? Similarly, if you have to find out the values of C21, C22, C23, C21 minus 1, this is known as C21. So minus 1 raised to 2 plus 1. N is equal to numbers of the column and represents numbers of the column. So remainings are, so this is the second row and first column. It means remainings are first row, second row, first column. Second row, first column. Remainings are 4, 3, 3, 2 is equal to minus 1 raised to 3, 6 minus, 8 minus 9. So minus 1 is equal to plus 1. So the value for C21 is equal to plus 1. Similarly, C22 minus 1 raised to 2 plus 2. So remainings are, this is the second row, second column. So remainings are 1, 3, 1, 2. Minus 1 raised to 4. And remainings are 2 minus 3 is equal to minus 1. So the value for C22 is equal to minus 1. Similarly, C23, number of the rows, second, numbers of the column, 3. So remainings are second row, third column, 1, 4, 1, 3. Second row, second row, third column, 1, 4, 1, 3 is equal to minus 1 raised to 5, 3 minus 4 is equal to plus 1. So the value for C21, C23 is equal to plus 1. C C31. Similarly, this is the third row, first column, minus 1, 3 plus 1. So remainings are 4, 3 minus 1, 0 is equal to minus 1 raised to 4, 0 minus minus plus 3 is equal to C31. The value for C31 is equal to plus 3. Minus 1 raised to, just a minute, it should be 1 and 0. So the value is minus 3, minus 3. So the value for C31 is equal to minus 1. C32 minus 1 raised to 32. So remainings are, this is the second column and third row and second column. Remainings 1, 2, 3, 0. This is the second element, second column and third row. So remainings are 1, 3, 2, 0 is equal to minus 1 raised to 5. It means minus 1. And remainings are 0 minus 6 is equal to plus 6. So the value for C32 is equal to plus 6. C33 minus 1 raised to 3 plus 3, third row and third column. So remainings are, this is the third column, third row. Remainings are 1, 4, 2, 1 is equal to 1, 1 minus 8 is equal to minus 7. So the value for C33 is equal to minus 7. So next step is the arrange all these values in a proper position. So C11 2, C12 minus 4, C13 5, C21 1, C22 minus 1, C23 1, C31 minus 1, C32 plus 6, C33 minus 7. Now addition A is equal to, we have to arrange the number of the rows into numbers of the column, just like this one, 2 minus 4, 5, 1 minus 1, 1, minus 1, 6, minus 7. So this is known as addition A. This is known as addition A. So A inverse is equal to addition A divided by determinant of this matrix. So is equal to 2, 1 minus 1, minus 4 minus 1, 6, 5, 1 minus 7. So after all, this can be represented as 2 by 1, 1 by 1, minus 1 by 7, minus 4 by 7, 1 by minus 1 by, just a minute, minus 1 by 1, minus 4 by 1, minus 1 by 1, 6 by 1, 5 by 1, 1 by 1, minus 7 by 1. So is equal to 2, 1, minus 1, minus 4, minus 1, 6, 5, 1, minus 7. So this is the inverse of the matrix, of the three-dimensional matrix. So dear students, first of all, we have to find out the determinant of this matrix and then find out the values of C11, C12, C13, C21, C22, C23, C31, C32, and C33, and arrange the numbers of the rows into numbers of the column and divide each element of this matrix by the determinant of this matrix. So this is the how to find out the determinant of the three-dimensional matrix. So exam point of view, how to find out the inverse for the two-dimensional matrix and the three-dimensional matrix. These are the most important. Now we are going for the next title, is the order of a group. Order of a group can be represented by small h. Can be represented by small h. And what is order of a group? Order of a group is equal to numbers of the symmetry elements are present in a molecule. So dear students, remember that how to find out the determinant of this matrix, how to find out the order of a group. Order of a group is nothing but the numbers of the symmetry elements are present in a molecules. As for example, water molecule. Water molecule consists E, C2, sigma V X Z, and sigma V Y Z symmetric elements. So dear students, remember that water molecule consists how many symmetry elements? E, C2, sigma XZ, and sigma V YZ symmetry elements. So dear students, in our topic, two molecules are the most important, water molecule and ammonia molecule. So we have to remember the symmetry elements of the both these molecules. So water molecule consists E, C2, sigma Vxz, and sigma Vy is the symmetry elements. So here, numbers of the symmetry elements is equal to 4. So order of a group for water molecule is equal to 4. In case of ammonia molecule consists E C3 plus or C3 1, C3 minus or C3 2, sigma V1, sigma V2, and sigma V3 symmetry elements. Ammonia molecule consists how many symmetry elements? 1, 2, 3, 4, 5, and 6. It means order of a group for the ammonia molecule is equal to 6. So, dear students, order of a group is equal to numbers of the symmetry elements present in that molecule. Third molecule is BF3 molecule. BF3 molecule consists E C3 plus, C3 minus, 3C2, sigma H, twice as 3, 3 sigma V. So here, number of the symmetry elements is equal to 12. So order of a group for BF3 molecule is equal to 12. So anyhow, order of a group can be represented as numbers of the symmetry elements are present in that molecule. Now next level is the how to find out the class or what is geometrical transformation. Okay, now one group consists X, A, B, C. These are the symmetry elements of a particular group. X, A, B, C. These are the different symmetry elements of a particular group. Now, if first one, X inverse A into X is equal to A. What is X inverse? X inverse is the inverse symmetry operation of X. X inverse is the inverse symmetry operation of X. X, A, B, C. These are the different symmetry elements of a particular group. If X inverse A into X is equal to A, it means A is conjugate to itself to form an individual class. So according to this condition, A itself conjugate to form a single class. So dear students, remember that how to find out the class? We have to go for the three properties. First property is X inverse A into X is equal to A. It means A is conjugate to A itself to form an individual class. X inverse A into X is equal to B. It means A and B conjugate to each other to form a combined class. Here again, X inverse is the inverse symmetry operation of X. X inverse is the inverse symmetry operation of X. X inverse A into X is equal to B. It means A and B conjugate to each other to form a combined class. So this is the second condition. Now what is B over here? B is the similarity transformation of A by symmetry operation X. What is B? B is the similarity transformation. B is the similarity transformation of A by symmetry operation X. So dear students, first conjugate property is X inverse A into X is equal to A. It means A is conjugate to form an individual class. X inverse A into X is equal to B. It means A and B conjugate to one another, conjugate to each other to form a combined class. Or we can say B is the similar transformation of A by symmetry operation A. symmetry operation X. Dear students, this is also most important question for your exams. What is similarity transformations? Give the numbers of the classes or explain the numbers of the classes in case of either water molecule or ammonia molecule. So first of all, we have to go for the definition of similarity transformations and then conjugated properties. Third property is x inverse A into x is equal to B and x inverse B into x is equal to C. It means A, B, C conjugate to one another to form a combined class. A, B, and C conjugate to one another to form a combined class. So, dear students, with the help of these three conjugated properties, we can assign a class of any molecules. So, repeat again. First, x inverse A into x is equal to A. It means A is conjugate to A itself to form an individual class. X inverse A into x is equal to B means A and B conjugate to each other to form a combined class. X inverse A into x is equal to B and x inverse B into x is equal to C. It means A, B, and C conjugate to one another to form a combined class. So let us start with the first example. Water molecule. Water molecule consists A, C2, sigma Vx sigma V, Y symmetry elements. Water molecule consists four symmetry elements E, C2, sigma Vx and sigma V, YZ symmetry elements. Now, whenever we talk about the character table for water molecule, E, C2, sigma Vx sigma V, YZ. Okay, that means numbers of the classes is equal to 4 in case of the water molecule. So we have to prove this numbers of the classes in case of the C2V point group or water molecule is equal to 4. E is conjugate to itself, C2 conjugate to itself, sigma Vx conjugate to itself, and sigma Vy conjugate to itself. Means the symmetry elements of the water molecule satisfy the conjugate properties number 1, that is x inverse A into x is equal to A. So let us start with the first E. E inverse E into E. C2 inverse E into C2. Sigma Vxz inverse E into sigma Vyz. Sigma Vyz inverse into E sigma Vyz is equal to is equal to is equal to is equal to. Now this can be satisfied any one property. X inverse A into x is equal to A. X inverse A into x is equal to B. And third one is x inverse A into x is equal to B. X inverse B into x is equal to C. Okay, this is first condition. This is second conjugate properties. This is third conjugate properties. Okay, so we have to go for the any one properties for the water molecule. So if we go for the first, water molecule, first of all E inverse, and we know that what is identity symmetry operation? We have to do nothing by identity symmetry operation, and it inverse that will be the same. So we have to do nothing. So H1, H2 remains as it is. Then again identity. So there is no change in the position of the hydrogen. Again E. So there is no change. So after all, it is E. It means this can satisfy the condition number 1, that is x inverse A into x is equal to A is equal to A. It means A is conjugate to itself, means E is conjugate to E itself to form an individual class. C21 inverse. Okay, C21. What is C21? It means we have to rotate these molecules along the symmetry axis around 180. And it inverse, that will be the same in case of the water molecule. Either clockwise or anti-clockwise, both are the same. H2 to H1. Then E means it remains as it is. Then again C2, H1, H2 to give the original position of the water molecule. It means the result is identity. Third one, sigma V x z inverse. Sigma V x z inverse means sigma xz. Sigma xz means there is no change in the position of the hydrogen of the water molecule, hydrogens of the water molecule. Similarly, it inverse will be the same. So there is no change in the position of the hydrogens. Again, identity, there is no change in the position of the hydrogens. Again, sigma V xz, there is no change in the position of the hydrogen of the water molecule. So overall result is identity. Now, fourth one, sigma V xz inverse. Sorry, yz inverse. Sigma V yz, it means we have to put a mirror over here. So to change the position of the hydrogens, so H2 and H1, it means its inverse will be the same. Again, identity H2, H1. Again, sigma V yz to give the original molecule of the water molecule. So is equal to identity. So first of all, if we operate identity symmetry operation with the conjugate properties, which can satisfy the condition number one, that means E is conjugate to E itself to form an individual class. It means in case of the water molecule, E is conjugate to itself to form an individual class. Now, similarly, if you go for the second one, C2, 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 and C2, and find out the changes. First of all, E inverse, that will be the same. C2 inverse means we have to rotate these molecules along the imaginary axis around 180 to give H2, H1. Again, E, H2, H1. So overall result is C2 or C21. Both are the same. C21 or C2. Both are the same. Similarly, if you go for the C2 inverse, it means 2 and 1. Again, C2, C21. This is C2 or C21. Both are the same. 1 and 2. Again, C2, 2 and 1. So overall result is C21 or C2. Third one is sigma V xz inverse. By operating sigma V xz, molecule remains as it is, that is H1 and H2. C21, H2, H1. Again, sigma V xz, H2, H1 to give the original position to give the H2, H1. So again, C21. And then sigma V YZ, sigma V YZ inverse, H2, H1, C21, H1, H2. Again, sigma V XZ. So H2, H1. Again, inversion of the configuration. So this is again C21. So in case of the C2, C2 is conjugate to itself to form a individual class. So in case of the water molecule, C2 is conjugate to itself to form a individual class. Similarly, third element of the symmetry operation is sigma V XJ. Sigma V XJ. So in case of E inverse sigma V XL into E, first of all, E inverse means there is no change in the position of the hydrogens. Sigma V XZ. By operating sigma V XZ in case of the water molecule, there is no change. H1, H2. Again, identity. So there is no change in the position of hydrogens is equal to sigma V XJ. Next one, C2 inverse, sigma V XZ. C2 inverse, it means it is nothing but the C2, 2 and 1. Sigma V XZ. So there is no change. Again, C2, 1. So this is nothing but the sigma V XZ. Similarly, sigma V XZ inverse, sigma V XZ, sigma V XZ, it is sigma V XZ. Now, in case of sigma V YZ, sigma V YZ inverse is equal to sigma V YZ inverse H2 H1. Sigma V YZ and it inverse both are the same. Sigma V XZ as it is H2 H1. Again, sigma V YZ is equal to 1 and 2. It means sigma V XZ. Okay. So third element of the water molecule conjugate to itself. So sigma V XZ conjugate to itself to form a individual class.
Excuse me, sir.
Yes, yes, please.
સર થોડું બ્લર આવે છે.
Ah, just a minute. I will check the net. Okay.
જી સર, જી સર.
Hello, madam. Is it okay?
ના સર, બ્લર જ છે એકદમ સ્ક્રીન.
Okay. આપણે એક 5 2 મિનિટ પછી આપણે 5
હા હા
10 મિનિટ બ્રેક આપી દઈએ હે ને. 10 મિનિટ બ્રેક
હા
પછી પાછું. Okay,
હા હમ
just a minute. Now, in the case of the last symmetry elements, we already discussed about the third symmetry elements conjugate to itself to form an
sir,
individual.
screen is not visible, sir.
Okay, okay. આપણે 10 મિનિટનો બ્રેક લઈ લઈએ. Okay,
Okay,
then we
okay.
will meet again. Okay, thank you, madam.
Dear students, we will have a 5-minute break. We'll check the internet and we will be back soon. Hello, sir.
Hi, yes. Is it visible?
જી સર.
Okay.
હા
તો
હા.
આપણે ક્યાંથી સ્ટાર્ટ કરીએ ફરી પાછું? અડધો કલાકથી નથી દેખાતું. ઓકે.
આમાં છે ને
હા.
ઇન્વર્ઝન ઓફ મેટ્રિક્સ મેસેજ છે
ઓકે
સ્ટુડન્ટનો.
ઓકે fine. Okay, dear students, again we are going for the inversion of how to find out the inverse of the matrix. To find out the inverse for the two-dimensional matrix and the three-dimensional matrix, both are the different. In case of two-dimensional matrix, inverse of any matrix, suppose A, it can be represented as a A inverse. As for example, the two-dimensional matrix, suppose this one is the two-dimensional matrix. How to find out the inverse for the two-dimensional matrix? It consists 4 stages. First of all, we have to find out the determinant of this matrix is equal to combination of diagonal elements minus other than diagonal elements. It means 8 to the minus 5 3 is equal to 16 minus 15 is equal to
સર,
yes.
હેલો સર.
yes,
વોઇસ
yes.
સ્લો આવે છે એકદમ. સ્ક્રીન
Okay.
પ્રોપર છે બટ વોઇસ નહીં આવતો.
Okay, fine. Voice. Hello. Hello. Hello, Khushbu madam. Hello.
જી સર.
હવે સંભળાય છે?
સ્લો જ છે સર.
સ્લો છે. Just a minute. Huh? Hello.
જી સર, વોઇસ
Hello.
આવે છે પણ એકદમ ડીમ વોઇસ આવે છે.
Okay. Just a minute.
સર તમે કન્ટિન્યુ કરો, પછી વોઇસ એકદમ લો હોય તો ફરી તમને હું રિમાઇન્ડ કરું.
Okay. Now, how to find out the inverse of this matrix? To find out the inverse for the two-dimensional matrix, first of all, we have to find out the determinant of this matrix and then change the position of diagonal elements. Third step, to change the sign of other than diagonal elements. And last stage, divide each element of this matrix by the determinant of this matrix. Okay, so is equal to 2 minus 3 minus 5 8. So dear students, exam point of view, how to find out the inverse for the two-dimensional matrix and the three-dimensional matrix, these are the most important. So how to find out the inverse for the two-dimensional matrix? First of all, find out the determinant of this matrix. Second step, to change the position of diagonal elements. Third step, change the sign other than diagonal elements. And finally, divide each element of the matrix by the determinant of this matrix. Now, in case of how to find out the determinant for the three-dimensional matrix, A is equal to 1 4 3 2 1 0 1 3 2. Now, to find out the inverse for the three-dimensional matrix, first of all, we have to find out the inverse of the determinant of this matrix. A is equal to 1. Remainings are 1 0 3, 2. Minus 4, remainings are 2, 0, 1, 2. Plus 3, 2, 1, 1, 3. Okay. Just 1, remainings are 1, 0, 3, 2. Minus second element of the first row, minus 4, remainings are 2, 0, 1, 2. Plus 3, remainings are 2, 1, 1, 3. Is equal to 1, 2 minus 0, minus 4, 4 minus 0, plus 3, 6 minus 1 is equal to 2 minus 16 plus 15 is equal to 1. So determine for this three-dimensional matrix is equal to 1. A inverse is equal to adjacent A divided by determinant of this matrix. Okay, we already find out the determinant of this matrix. Now, adjacent A, to find out the adjacent A, we have to find out the value of C11, C12, C13. So how to find out the value of C11 is equal to m raised to n and remaining two-dimensional matrix is equal to minus 1. So first of all, first element of the first row, first column is equal to 1 plus 1. Remaining matrix, first row, first column, so remaining 1, 0, 3, 2 is equal to minus 1 raised to 2. 2 minus 0 is equal to plus 2. So the value for C11 is equal to plus 2. C12 minus 1 is to first row, second column. Remaining matrix, remainings are 2, 0, 1, 2 is equal to minus 1 raised to 3, 4 minus 0 is equal to minus 1 raised to 3 is equal to minus 1 and 4. It means the value is minus 4. C13 is equal to minus 1, 1 plus 3. So remaining values 2, 1, 1, 3 is equal to minus 1 raised to 4, 6 minus 1 is equal to plus 5. So values for C11, C12, C13 C11 is equal to plus 2, C12 is equal to minus 4, C13 is equal to plus 5. Similarly, C12, C21 is equal to minus 1 raised to 2 plus 1. C21, it means second row, first column. So remainings are 4, 3, 3, 2. Second row, first column. So remainings are 4, 3, 3, 2 is equal to minus 1 raised to 3, 8 minus 9. So minus 1 is equal to plus 1. So value for C21 is equal to plus 1. C22 is equal to minus 1 raised to 2 plus 2. Second row, second column. So this is the second row and second column. So remainings are 1, 3, 1, 2 is equal to minus 1 raised to 4. It means plus 1. 2 minus 3 is equal to minus 1. So value for C22 is equal to minus 1. C23 is equal to minus 1 raised to 2 plus 3. So this is the second row and third column. So remainings are 1, 4, 1 3 is equal to minus 1 is to 5 is equal to minus 1, and 3 minus 4. So plus plus minus minus is equal to plus 1. So value for C23 is equal to plus 1. C31 minus 1 is to 3 plus 1. This is the third row and first column. Third row, first column. So remainings are 4 3 1 0 is equal to 0 minus 3. So minus 1 raised to 4. 3 plus 1 is equal to plus 1, and this is minus 3. So the value for C31 is equal to minus 3. C32 is equal to minus 1 raised to 3 plus 2. So remainings are third row, second column, 1 1 2 3 0 is equal to minus 1 is to 5 means minus 1, 0 minus 6 is equal to plus 6. So the value for C32 is equal to plus 6. C33 is equal to minus 1 raised to 3 plus 3. The remainings are third row, third column, 1 4 2 1. Third row, third column, 1 4 and 2 1 is equal to 1 minus 8 minus 1 plus 1, 1 minus 8 is equal to plus 1 and minus 7. It means minus 7. So the value for C33 is equal to minus 7. So dear students, these are the values of C11, C12, C13, C21, C22, C23, C31, C32, and C33. Now we have to arrange all these values in a matrix. 2 minus 4 plus 5, 1 minus 1 1, minus 3 6, minus 7. Then adjacent A. Adjacent A is nothing but the arrange this value row number of rows into numbers of the column. So 2 minus 4 5, 1 minus 1 1, minus 3 6, minus 7. So this is the adjacent A. So A inverse is equal to adjacent A divided by determinant of this matrix is equal to adjacent A 2 1 minus 3 minus 4 minus 1 6, 5 1 minus 7. Divided by 1. Or we can say it can be represented as 2 by 1, 1 by 1, minus 3 by 1, minus 4 by 1, minus 1 by 1, 6 by 1, 5 by 1, 1 by 1, minus 7 by 1. So is equal to 2 1 minus 3, minus 4 minus 1 6, 5 1 minus 7. Okay, so this is the inverse of this matrix. This is the inverse of this matrix. Now next method is the order of X, order of a group. Order of a group can be represented by small h. And what is order of a group? Order of a group can be represented as a number of the symmetry elements are present in a molecule. As for example, this is water molecule. In case of water molecule, it consists E, C2, sigma Vx, sigma Vy symmetry elements. So water molecule consists 1, 2, 3, and 4. So order of a group for water molecule is equal to 4. So what is order of a group? Numbers of symmetry elements are present in a molecule. Second molecule is ammonia. So dear students, in this topic, we have to remember the symmetry elements of the water molecule and ammonia molecules. E, C3 plus or C3 minus, C3 plus or C31, C3 minus or C32, sigma V1, sigma V2, and sigma V3. So here numbers of the symmetry elements is equal to 6. Means order of a group for ammonia molecule is equal to 6. In case of the BF3 molecule consists E twice C3 as a C3 plus C3 minus, 3C2 sigma H twice S3 and 3 sigma V. So in case of the BF3 molecule, order of group is equal to 12. So dear students, what is order of a group? Order of a group is nothing but the numbers of the symmetry elements are present in a molecule. Now next title is the class. How to find out the class of any molecule? So in case of class, we have to go for the 3 conjugated properties. Suppose X, A, B, C. These are the different symmetry elements of a particular group. If X inverse A into X is equal to A, it means A is conjugate to itself to form an individual class. X inverse A into X is equal to B. It means A and B conjugate to each other to form a combined class. Okay. X, A, B, C. These are the different symmetry elements of a particular group. If X inverse A into X is equal to A, it means A is conjugate to itself to form an individual class. X inverse A into X is equal to B. It means A and B conjugate to each other to form a combined class. Or we can say B is the similarity transformation. B is the similarity transformation of A by symmetry operation X. So dear students, this is the most important questions for our exams. What is similarity transformations? Explain how to find out the classes of the water molecule or ammonia molecule. So what is similarity transformations? In case of X inverse A into X is equal to B. So here B is the similarity transformation of A by symmetry operation X. What is similarity transformation? B is the similarity transformation of A by symmetry operation X. Third one, X inverse A into X is equal to B and X inverse B into X is equal to C. It means A, B, C conjugate to one another to form a combined class. A, B, C conjugate to one another to form a combined class. And with the help of these conjugated properties, 3 conjugated properties, we can assign a class of any molecules. So, dear students, let us start with the first example of the water molecule. in case of water molecule, consists E C2 sigma Vxz sigma V YZ symmetry element. So whenever we talk about the character table for water molecule, it is just like a E C2 sigma Vxz sigma V YZ symmetry elements. Okay, in this case, this is first, second, third, and fourth. In case of water molecule consists 4 symmetry elements and class is equal to also 4. 1, 2, 3, and 4. So water molecule consists 4 symmetry elements and the numbers of the classes is equal to 4, and that we have to prove it. So let us start first with the conjugate property E inverse E into E is equal to C2 inverse E into C2 is equal to sigma Vxz inverse E into sigma Vxz is equal to sigma Vyz inverse E into sigma Vyz is equal to. So let us start with the first example as a water molecule. Okay, E inverse. In case of identity symmetry operation, if we operate identity symmetry operation, molecule remains as it is, that is H1, H2. Then E, first one, E inverse E into E. E means there is no change in the position of the hydrogen. Again, E is equal to identity. So there is no change in the position of water molecule. Second one, C2 inverse E into C2. So C2 inverse. C2 means we have to operate this molecule along the imaginary axis around 180 to change the position of this hydrogen. Similarly, in case of C2 inverse, means this is anti-clockwise rotation. So clockwise rotation, anti-clockwise rotation in case of the water molecule both are the same to change the position of this hydrogen. Again, identity. So there is no change in the position of this hydrogen. Again, C21 to give the original molecule. It means there is no change, means identity. Third one, this one is the water molecule. If we operate sigma Vxz inverse. Okay, dear students, sigma Vxz means there is no change in the position of this hydrogen. So its inverse answer will be the same. Again, identity, again same. So there is no change in the position of the hydrogen. Again, identity. If we operate sigma Yz inverse, Yz, it means we have to bisect the molecule or we have to put a mirror over here to change the position of these hydrogens, H2 and H1. Again, identity, H2, H1. And then Yz to give original molecule. It means E. So overall result is identity. So this can satisfy the condition number 1, X inverse A into X is equal to A. It means A is conjugate to A itself to form an individual class. So in case of water molecule, E is conjugate to itself to form an individual class. Okay. So remember that first class of the water molecule is a identity as a first element or first class. Second element is C2 inverse, C2, C2 or C21, both are the same. And to find out the result. In case of, if you operate C2 E inverse, there is no change in the position of this hydrogen. then C2 or C21 to give the H2 and H1. Again, identity 2 and 1. So this is nothing but the C2 or C21. Both are the same. So next, C2 inverse. We already discussed that. In case of the water molecules, C2 or C2 inverse, both are the same. So if we operate C2 inverse, H2, H1, again C2, H1, H2, and again C2. So overall result is C2. Third one is sigma V XZ inverse. So by operating sigma V XZ, the position of the hydrogens remains as it is. So there is no change by operating sigma V XZ inverse. Then C2, H2 to H1. Again sigma V XZ. So there is no change, H2, H1. So again C2. Third one, sigma V XZ inverse. Sorry, fourth one, sigma V YZ inverse. By operating sigma YZ inverse, sigma V YZ to change the position of this hydrogen. Similarly, in case of sigma V YZ inverse, to change the position of this hydrogen. Again C2, H1, H2, and again sigma V YZ to give H2 and H1. So overall result is C2. It means this can also satisfy the condition number 1. X inverse A into X is equal to A means A is conjugate to itself to form an individual class. So in case of the water molecule, the second class is C2 itself. Similarly, if we go for the third one, sigma V XZ, 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 E, C2, sigma V XZ, sigma V YZ. E inverse to give H1, H2. Sigma V XZ. So there is no change in the position of this hydrogen. Again, identity to give H1, H2. So overall result is sigma V XZ. Similarly, if we operate C21 inverse to change the position of this hydrogen, again sigma V XZ to give 2 and 1. Again C2 to give H1 and H2. So overall result is sigma V XZ. Sigma V XZ inverse, sigma V XZ, sigma V XZ. So overall result is sigma V XZ. Next one is sigma V YZ inverse. To change the position of this hydrogen, then sigma V YZ, and then sigma V YZ to give the original molecule. Or we can say this is nothing but the sigma V XZ. It means sigma V XZ conjugate to itself to form a individual class. So third class of the water molecule is equal to sigma V XZ. Now last one is fourth class of the water molecule, which is related with the sigma V YZ. Sigma V YZ inverse E sigma V YZ. sigma v yz inverse C2 sigma v yz. E inverse sigma v yz E C2 inverse sigma v yz C2 sigma v xz inverse sigma v yz sigma v xz sigma v yz inverse sigma v yz sigma v yz is equal to, so operating sigma v yz xy sigma v yz. Next, C2 inverse, it means H2 to H1 sigma v yz H1 H2 and then C2, so H2 H1, it is nothing but the sigma v yz. Similarly, sigma v xz sigma yz, so it is sigma v yz. Over here, sigma v yz inverse sigma yz sigma yz, so overall result is sigma v yz. So dear students, so fourth class of the water molecule is a sigma yz itself to conjugate to itself to form a individual class. So in case of the water molecules, number of the symmetry elements 1, 2, 3, 4. Numbers of the class is equal to also 4 in case of the water molecule. So dear students, we are going for the another example is ammonia molecule. In case of ammonia molecule, it consists E C3 plus or C31, C3 minus, sigma V1, sigma V2, and sigma V3 symmetry elements. So ammonia molecule consists 6 symmetry elements: 1, 2, 3, 4, 5, and 6. In case of ammonia molecule, E conjugate to itself to form an individual class. C3 plus C3 minus conjugated to each other to form a combined class. Sigma V1, sigma V2, sigma V3 conjugate to one another to form a combined class. That is we have to prove ammonia molecule consists 3 classes. First one is identity. C3 plus C3 minus conjugate to each other to form a combined class. Sigma V1, sigma V2, sigma V3 conjugate to one another to form a combined class. That is we have to prove it. Okay, so ammonia molecule consists E, C3 plus C3 minus, sigma V1, sigma V2, sigma V3. So let us start first with the identity. E inverse E into E. C3 plus inverse E into C3 plus. C3 minus inverse E into C3 minus. Sigma V1 inverse E into sigma V1. Sigma V2 inverse E into sigma V2. Sigma V3 inverse E into sigma V3. Okay, E inverse E into E is equal to E. That is we know very well. In case of ammonia molecule, 1, 2, and 3. C3 plus inverse. So dear students, remember that C3 plus, it means one time clockwise rotation. And C3 plus inverse, it means one time anti-clockwise rotation. So 1, 2, and 3. Then identity. Identity means as it is. Again C3 plus to give H1, H2, and H3. To give the original molecule, it means overall result is identity. The next one is C3 minus inverse. C3 minus inverse. Okay, we already discussed about the C3 plus. C3 minus inverse. C3 minus means one time anti-clockwise rotation, and C3 minus inverse means one time clockwise rotation. 1, 2, and 3. Again, identity. 3, 1, and 2. Again, C3 minus. Again, C3 minus means one time anti-clockwise rotation. So to give original molecule, it means identity. Next one is C3 minus inverse, sigma VA inverse. Okay, sigma VA means we have to put a mirror over here to change the position of hydrogen 1 and 3. 2 and 3. If we put a mirror on this hydrogen 1 to change the position of 2 and 3. Similarly, if we put a mirror on hydrogen 2 to change the position of 1 and 3. If we put a mirror over on the hydrogen number 3 to change the position number 1 and 2. So what will happen over here? Sigma V1 inverse means it will be the same. So 1 remains as it is. 3 and 2 interchanged. Sigma VA inverse. Then sigma V1 inverse or sigma VA inverse. Both are the same. Hydrogen 3, hydrogen 1, hydrogen 2. Again, sigma V1 or sigma VA. Both are the same. H1, 2, and 3. To give the original molecule, it means identity. Similarly, here over identity. So overall results for the identity symmetry operation as an identity. It means E is conjugate to itself to form an individual class. So in case of the ammonia molecule, E is conjugate to itself to form a individual class, or first class of the ammonia molecule is identity only. Next one is C3 plus. In case of ammonia molecule, we have to remember that rotation followed by the reflection. So we have to consider the before the reflection position of these hydrogens. So dear students, remember that if we operate rotation followed by the reflection, so before reflection we have to consider the original position before the rotations, symmetry operations. So let us start. E inverse C3 plus E is equal to C3 plus. C3 plus inverse C3 plus C3 plus. This is 1, 2, and 3. If we operate C3 plus inverse, C3 plus inverse. C3 plus means one time clockwise rotation, and C3 plus inverse means one time anti-clockwise rotation. 1, 2, and 3. Again, C3 plus. One, 2, and 3. Again, C3 plus. 1, 2, and 3. So overall result is C3 plus. Overall result is C3 plus. C3 plus, C3 plus, C3 minus. Okay. In case of C3 minus inverse, means one time clockwise rotation, 1, 2, and 3. Then C3 plus means 1, 2, 3. Again, C3 minus means overall result is C3 minus. Now this is important. If you operate sigma V1 inverse 1, 2 and 3, sigma V1 inverse 1 remains as it is, 3 and 2 interchange, then C3 plus. C3 plus means 1, 3 and 2. Now this is important. Rotation followed by the reflection. Rotation followed by the reflection means we have to consider the this is rotation followed by the reflection. Okay, here sigma V1, it means this symmetry operation will reflects with respect to hydrogen 1, position of the hydrogen 1, and we have to consider this position before the rotation. It means the position of the hydrogen 1 is over here, so we have to put a mirror over here. So H2 remains as it is, 3 and 1 interchange. So dear students, remember that sigma V1 inverse means 3 and 2 are interchanged, and then C3 plus means one time clockwise rotation. And in case of ammonia molecule, we have to remember that rotation followed by the reflection, we have to consider the before the rotation position of these hydrogens. So suppose sigma V1 means this respect to hydrogen 1, so we have to put a mirror over here on hydrogen 1. So the position of hydrogen 2 remains as it is, and 1 and 3 interchange. So this is nothing but the C3 minus. This is nothing but the C3 minus. Similarly, if you go for the sigma 2 inverse, sigma 2 inverse means we have to put a mirror over on the hydrogen. So 1 and 3 are interchanged to as it is. Then C3 plus, it means 1, 3 and 2. Again sigma V2. So this is again rotation followed by the reflection, and this is the position of the sigma V2 or hydrogen 2. So we have to put a mirror over here. So 3 remains as it is, 1 and 3 interchange. Sorry, 1 and 2 interchange. So this is nothing but the C3 minus. This is nothing but the C3 minus. Similarly, sigma V3. Sigma V3 inverse means 3 remains as it is, 2 and 1 interchange. C3 plus, it means one time clockwise rotation. Sigma V3. So this is the again rotation followed by the reflection. So the hydrogen 3 is over here. So position of the hydrogen 1 remains as it is, and 3 and 2 are interchanged. So this is C3 minus. So overall result is C3 plus or C3 minus. That means this can satisfy the condition number 2. A and B conjugated to each other to form a combined class. Similarly, C3 plus C3 minus conjugate to each other to form a combined class. So whenever we talk about the class of the ammonia molecule, it should be 2C3. So first one is identity, second one is 2C3, means C3 plus C3 minus conjugate to each other to form a combined class. Now third one. C3 minus, C3 minus, C3 minus, C3 minus, C3 minus. So what will happen? E inverse C3 minus E is equal to C3 minus. Okay, here C3 plus inverse and C3 minus and C3 plus. 1, 2, and 3. C3 minus inverse. C3 minus means one time anti-clockwise rotation. And C3 minus inverse, it means one time clockwise rotation. 1, 2, and 3. Then C3 minus. Just a minute. It is C3 plus inverse. So first of all, C3 plus inverse. C3 plus inverse. C3 plus means one time clockwise rotation, and it inverse means one time anti-clockwise rotation. 1, 2, and 3. This is one time anti-clockwise rotation. Again, C3 minus. Again, one time anti-clockwise rotation. 1, 2, and 3. Again, C3 plus. Again, C3 plus. C3 plus, it means 1, 2, and 3. And this is nothing but the C3 minus. Okay, C3 minus inverse. C3 minus. C3 minus inverse means C3 plus. C3 minus and C3 minus. Overall result is C3 minus. In case of sigma V1 inverse, 1, 2, and 3. Sigma V1 inverse. It means 1 remains as it is. 3 and 2 interchanged. And then C3 minus. Means one time clockwise, anti-clockwise rotation. 1, 2, and 3. Then again, sigma V1. This is rotation, again rotation followed by the reflection. It means sigma V1 before reflection and before rotation. This is the position of hydrogen 1. So we have to put a mirror over here. So 3 remains as it is. 2 and 1 interchange. So overall result is nothing but the C3 plus. I think it will be C3 plus. That is, we can assume. So overall result is nothing but the C3 plus C3 minus, and that is we already proved from the C3 plus or C3 minus. That is already be proved in the C3 plus. Now last one is sigma V1, sigma V1, sigma V1, sigma V1, sigma V1, sigma V1. You can take sigma VA, sigma VB, sigma VC also. What will be the result? Sigma V1. Hydrogen 1, 2, and 3. C3 plus inverse. C3 plus inverse means one time clockwise rotation, and it inverse means one time anti-clockwise rotation. 1, 2, and 3. Then sigma V1. This is again rotation followed by the reflection. So before, this is sigma 1, which corresponds to hydrogen 1. So the position of the hydrogen 1 before rotation is this one. So we have to put a mirror over here on the hydrogen 2. So 3 and 1 interchange. Again, C3 plus. C3 plus means one time clockwise rotation. Okay, so this is nothing but the sigma V2. This is sigma V2. Next one is C3 minus inverse sigma V2. C3 minus sigma V2. Sigma V, C3 minus inverse. C3 minus means one time anti-clockwise rotation, and the inverse means one time clockwise rotation. So 1, 2, and 3. This is the one time clockwise rotation. Then sigma V1. It should be sigma V1. Okay. Sigma V1. This is again rotation by followed by the reflection. So the position of the hydrogen 1 is over here. So we have to put a mirror over here, that is on hydrogen 3. 1 and 2 interchanged. Then again C3 minus means one time anti-clockwise rotation. So this is nothing but the sigma V3. This is again sigma V1. I think this is sigma V2 and this is sigma V3. So overall result is nothing but the sigma V1 or sigma V2 or sigma V3. Overall results will be the sigma VA or sigma VB or sigma VC. It means the third class of the ammonia molecule is 3 sigma V, or we can say sigma V1, sigma V2 or sigma V3 and sigma V3 conjugate to another to form a combined class. Or we can say ammonia molecule consists 3 classes, 1 identity, 2 rotational and 3 reflection. Similarly, we can go for the sigma V2. In case of sigma V2, E inverse sigma V2 E sigma V2. Now in case of C3 plus inverse sigma V2, one, 2, and 3, C3 plus inverse. Dear students, C3 plus means one time clockwise rotation, and its inverse means one time anti-clockwise rotation. 1, 2, and 3. Again sigma V2. This is again rotation followed by the reflection. Means we have to go for the sigma V2. Means position of hydrogen is 2. So hydrogen 3 remains as it is. 2 and 1 interchange. And then again C3 plus. So nitrogen, hydrogen, hydrogen. So what will happen? 1, 3, and 2. Compare this and this. So this is nothing but the sigma V3. This is nothing but the sigma V3. So similarly, it should be sigma V1. Next one is sigma V inverse, sigma V2, sigma V1. So third one is sigma V1 inverse. Sigma V1 inverse means 2 and 3 interchange, 1 remains as it is. Sigma V2 means 2 as it is, 1 and 3 interchange. Again sigma V1, 1 remains as it is, 3 and 2 interchange. So compare this and this. This is nothing but the sigma V3. Sigma V2, sigma V2, sigma V2, it is sigma V2. And over here, this is sigma V1. Okay. So overall, this is nothing but the sigma V1, sigma V2, and sigma V3. sigma v1 or sigma v2 or sigma v3, or we can say sigma va, sigma vb, sigma vc. It means sigma v1, sigma v2, sigma v3 conjugate to one or form a combined class. Similarly, for last one is 3. This is sigma v3. Now, if we operate C3 plus inverse sigma v3, 1, 2, and 3. C3 plus inverse means one time anticlockwise rotation. So 1, 2, and 3. Then sigma v3. This is again rotation followed by the reflection. So sigma v3 means position of hydrogen is 3. So we have to put a mirror over here on hydrogen 1. Hydrogen 1 remains as it is, 2 and 3 interchange. And then C3 plus. C3 plus means 1, 3, and 2. Compare this and this. So this is nothing but this sigma v1. It is sigma v2. This is sigma v3. Okay, sigma v1, sigma v3, and sigma v1. Sigma v1 inverse. 1, 3, and 2 interchanged. Again sigma v3 to change the position of 1 and 2. Again sigma v1. 1 remains as it is, 2 and 3 interchange. So compare this and this. This is nothing but the sigma v2 and this is sigma v1. So overall result is sigma v1 or sigma v2 and sigma v3. So dear students, how to find out the class in case of water molecule and ammonia molecule. Water molecule consists 4 symmetry elements and numbers of the classes is equal to 4. And in case of the ammonia molecules, number of symmetry elements is equal to 6 and numbers of the classes is equal to 3. First one is E conjugate to itself to form an individual class. C3 plus C3 minus conjugate to each other to combine class, and sigma v1, sigma v2, sigma v3 conjugate to one another to form a combined class. So I think this is enough for today's discussion. So dear students, sorry for some technical issues in this discussion. So thank you very much for listening me very silently. So we will meet on the next session on tomorrow.
Thank you,
Madam,
sir. Thank you, sir. Thank you very much for providing your valuable time for this webinar. Thank you, all the participants, for attending this webinar. And we will share tomorrow's session link very soon in your group. Thank you all. Have a nice day. Thank you, sir.
Thank you. Thank you.